Every atom has a radius. So this radius varies with the periods and groups. So normally, what do you think? From left to right, what happens? I'll explain like this. I told a factor code. Can you remember? Effective nuclear charge. Effective nuclear charge. I told a factor code. Effective nuclear charge. Can you remember that? What happened to this? Whenever you are moving from left to right, effective nuclear charge what will happen? It will increase. Effective nuclear charge will increase, right? In the same orbit. Same orbit. Shielding effect is 30. Same constant. Negligible. Right. Then, but what will happen for protons increasing? Because protons are increasing. What will happen to the effective nuclear charge? That will increase when you are going from left to right. When effective nuclear charge happens, what happens to these electrons? Effective nuclear charge increasing means what will happen? These electrons, this nucleus will pull the electrons closer to them. Right? So concentrate here. Don't look up and down. Look only the board that. Right. So what will happen to this electron? Between this electron and the nucleus, what will be there? Will be there. An attraction. Right? Then what will happen? When the protons are increasing, what will happen to these shells? What will happen? More than this will be small. Why? Because of effective nuclear charge, these shells they will pull towards them. More than that, the next one will be small. More than that, the next one will be small. More than that, the next one will be small. More than that, next one will be small. So there is a deviation like this. So what can you understand from left to right? The atomic radius will decrease due to increase of protons. Because of increase of protons is increasing the effective nuclear charge. Because of increasing the effective nuclear charge, what is happening? The size of the atom decreases. And is it understandable? Is it clear? E9. Okay. Next one is when you're going down the route. So left to right, then it is clear that now radius increases. So when you are coming from top to bottom, what might happen? Number of shells, what will happen to number of shells? Number of shells will increase. When number of shells is increasing, what happened to the size? Definitely size will decrease. Size will definitely increase. When new things are getting added, what will happen to the total size? The total size will increase. Make it in a main thing, right? So remember this. Don't forget that. Okay. That is what when going down the group, what happened? The size will increase. On the group, size will increase. More than what the other one. Okay. So the way why this is increasing? Because to increase of number of shells. Yeah, 100% clear neither. Yeah, charge will increase, but I said nuclear charge increase will not. Effective nuclear charge, what happened down the constant to reduces, slightly reduces. Effective nuclear charge reduces. Then because number of shells are increasing, its size will increase. You write it. So only write like this. When moving left to right, when moving left to right. The number of shells when moving left to right, the number of shells increases. When moving left to right, the number of shells increases. When moving left to right, the number of shells increases. When moving left to right, number of shells increases. Here, Hemma, you want it? You are? මොකද්ද ඔය උඩ දාගෙන ලියනවා ඒක. left to right number of shells increases. like what හිතේ තියෙන්නේ. I told one of my teacher things like this කියලා කිව්වා කොහොමද නේද? නේ අර කියන්නේ. Then moving left to right, what happens? When moving left to right, the number of shells walking on. The number of shells decreases. It decreases. Number of shells what's in there? Right? When moving left to right, right, moving left to right, moving top to bottom, left to right, left to right, top to bottom. When moving top to bottom, the number of shells increases. When moving top to bottom, the number of shells increases. When moving top to bottom, the number of shells increases. You got it? When moving top to bottom, the number of shells increases. Minimum. Therefore, the atomic radius will increase down the road. Therefore, atomic radius will increase down the road. Therefore, radius will increase down the road. Next point, like when moving left to right, the effective nuclear charge increases. When moving left to right, the effective nuclear charge increases. Therefore, it pulls the shell. Therefore, it pulls the shell towards the nucleus. 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 Therefore, when moving left to right, the radius will decrease. Therefore, when moving left to right, the radius will decrease. The radius will decrease. The radius will decrease. So if I ask you to compare, okay, two atoms, sodium and fluorine, who is bigger, who is smaller? Sodium is bigger, fluorine is smaller. Sodium is bigger, fluorine is smaller. Give me a minute. Right. Now say this. So when moving left to right, what will happen? When moving left to right, this one. So now I ask a question: which one is larger atom, sodium or fluorine? Which one is larger atom, sodium or fluorine? Sodium is larger atom. Why? Yes, sodium is here, fluorine is in this one. It likewise they can ask you to compare the radius of the atom. Right. At the same time, now I want to speak about. Have I given separately about anion and cations radius here? Question. How ionic radius varies in ion scale here? Okay. Now that is written in draw these things. Yeah. Draw color in the. Okay. You can show this sodium, magnesium, sodium, aluminium, phosphorus. Product you product draw. That running right. Which you put here and you want to go again and go and show. You can go downwards. Let's see. Can I understand? You can go up to chlorine. You can go. Okay, now I said the difference of what? The radius, how radius changes. Right. Come to the next page. So I have given there how this periodic table of the atomic radius, how the atomic radius are changing here. Electronic configuration of ions here or that theorem. Already I have given that electronic configuration of ions, right? Electronic configuration of ions. So electronic configuration of ions, how I have given that? Over there, how I have given that electronic configuration of ions. Over there, electronic configuration of ions. How I have given it. For example, I told about right? We'll take calcium 2 plus. Now you should put normal calcium in what? 1:2, calcium in 20, 2:2, 2b6, 3:3b6, 3d, 3d, 4. Okay. So calcium chloroblastin, what will happen? They will remove the electron. Mostly whenever they are removing electron, they will remove from the highest energy. Electron in the highest energy. What is the electron in the highest energy? 4s. Therefore, they will remove these two. Got the point? This calcium chloride. If I say zinc 2 plus how zinc 2 plus comes? 1 is 2. Normal zinc is what? 30. Normal zinc is 30. When you are writing this, you will have normally you get the numbers. 3 4 is 2 will have. You will finish this. There is zinc 2 plus 2, they will remove the electron from the highest energy level. But whenever they are filling, first 4 is get filled, then 3D only get filled. But whenever they are removing, they will remove from 4s. Zinc 2 plus 2, it will be in one here. Got the point? Same way, we'll think about Cl minus. Normal chlorine is 17. How you get 17 here? 1 is 2, 2 is 2, 2p6, 3 is 2, 3p5. And Cl minus what will happen? 1 electron will be added. When 1 electron gets added, 3p5 go to 3p6. 3p6. Is it understandable? You found the player or not? So this is the motion to mistakes. Right? First of all, write these electronic configurations and you write for these things. You just write these values. V3 plus, 19 plus. You write S2 minus. In the medium, you write these three here. Write for these two. Okay. What is the number of vanadium? 23. Vanadium is 23. So how will you write this 23? 1 is 2, 2 is 2, then 2b6, 3s2, 3b6. First of all, OH2 gets the 3d3. Right? This is the electronic configuration of an atom. So 3 plus here, who will remove this 3 plus? 2 from S, 1 from D. Is what? 3D. 2 will find this. Is it clear, guys? 100% clear. S2 minus K of sulfur is 16. Then you might wonder how I know these numbers quickly, how I'm telling sulfur 16, vanadium 23. It automatically we get to our head. When you go to a class, are you by hearting your classmates' names? He is Kamal, he is Sudhit, he is Jaga, he is Sana, he is Gona. No, right? We don't by heart names, but we remember the names. Likewise, it is you will used to that. Right? So these numbers, when you are working with the video table, so we can see how much you are involved with chemistry. You can tell the numbers when you have involved more. You can't tell the numbers when you have involved less. It's a what is phosphorus? 50. How the magnesium? 12. Argon 80. It can know. Right? Manganese structure 25. Right? Iron structure 26. Okay. Copper 29. At least up to 30 you should know. Again, when you are involved, you should know both. What involvement there? Magic maybe you get the periodic table. So S2 minus in this thing, and 1 is 2, 2 is 2, 2b6, 3 is 2, 3b2. So when they get these 2 electrons, 3p4 will go up to 3b. What? 3b6 second. When the medical, do you understand? Now we have these things. Okay. We'll go to the next one. Now question is they have asked, describe the ionic 35. Right. How ionic radius varies in ions. So I have given here some pictures. Suppose you are having the tube, you can see the pictures. How ionic radius varies in ions. How it varies, how it changes. Now remember, when an electron removed, what happens? Okay, then sodium is there. It is like this. When sodium remove an electron, it will shrink like this, but a small million. We are very small. Sodium is like this, means sodium plus is but a small. Because when they remove an electron, they become even smaller. Why? Because their outer electron is get removed. But when the electron is removed, now just imagine. This is a tugboat. You know tugboat. Tugboat, you know tugboat. Tugboat. Tugboat means a combine. Pulling the ropes and then you got tugboat. Right? So we'll say we have the 5 people are here, 5 people are this side. They are pulling both sides, they are pulling this. Now you are just removing one person from this, it becomes 4 students. Suddenly these people will come to this side. That's a Comrade. We are going to put it out. Which one? I don't know. They can do that. Okay. It's out. So what will happen? Directly, this will go to this side. Now imagine now this electron also in a system. You also have some attraction and they are maintaining that circle. So when one electron is removed, what will happen to this circle? This main phase will pull them even closer to them. So sodium plus become very smaller than sodium. Got the point? A by it means electron is trying to get for this side, plus is trying to get this side. Okay, because in the sodium, between electron and electron, this electron trying to get this electron to this side. This nucleus is trying to get the electron to this side. So there is a war. That's why I drew in the earlier repulsion and attraction. So what happens here? The mehemer will walk cannot. Right? Yeah, then what will happen to Earth? Anion. For positive ion is what we will say for this? Cation. So cation radius become very small. Then anion CL is like this. Then when you gain an electron, it becomes ultra large. No, CL minus. Why? Because between plus and minus there is a equilibrium. When one minus get added, what will happen? The effective nuclear charge can. Right? Effective nuclear charge. What will happen to the effective nuclear charge? What will happen to the healing effect? Right? So they will change. In the amount real minus, it becomes ultra large. Okay, because another electron get added, therefore the electron pool become larger. When the electron pool become larger, they become larger. Okay, because there is a pool around it. Right? You will learn later. Standard there is a pool, like a pool. When one electron has, the pool become larger. Next week continue. Right? Then next week, we are here to